Hey guys, how are you? This is Professor Charles from the Professor Chica's channel. In this video, I'm going to bring you a very interesting problem from MIT, and that you. It is. Exactly that. And he's here. Simplify this algebraic fraction as much as possible, right? And we're going to use here basically factorization. Exactly what you've learned in the 8th and ninth grade. That's what you'll need to use here to solve this problem, right? So, can you solve it? I suggest you pause the video now, try to solve it on your own here. Comment if you succeeded, like, and subscribe to the channel, that helps a lot. Let's go then to the resolution. Well guys, here's the thing, we're going to use factorization, right? Simple factorization technique. And if you observe, how do we solve problems of this type? Generally, when we want to simplify an algebraic fraction, basically, we're going to have to factor numerator to try to simplify with the denominator, or even have to factor numerator and denominator, right? As for the numerator as the denominator to be able to simplify. And here, as you can see, looking at the numerator, what do we have here? We have x to the power of 6 and x to the power of 3. And then it's very simple to observe this. Which technique are we going to be able to use? That of putting a common factor in evidence. In this case, the x to the power of 3 will be highlighted. Okay, we can build the numerator this way here. But if you do that, you'll realize that you won't be able to simplify it with anything down here, okay? So, we will also need... Hard to see, right? Why? Because here we don't have common factors, right? And also here it's difficult. You're seeing here x to the power of 6 to the power of 4, y to the squared. Anyway, you may have difficulty seeing, but I'm going to tell you here. What are you going to use here? It's going to use the difference of squares. Yes, difference of squares. And then you can ask the teacher, where is it? Is there only the y2 here? I can't see the squares. Yes. I've heard Mancebo. Calm down, I'll help you. Notice this, okay? We don't have squares here much. What do you mean, Professor? Simple. Let's do this x squared. I basically used properties of potentiation. 3 times 2, I go back to 6, so we've got here the x to the power of 3 squared. I made a square appear. Subtraction minus, I'm going to make square appear here as well. How? Same thing. I'm going to take the a, leave it here squared, and just the y and all of that squared. Again, I used potentiation properties. 2 times 2 goes back to 4. 2 times 1 goes back to 2. Is that right? So now we have here one guy squared minus another guy squared. And for those who don't remember, what is this factorization technique? I'll remind you here. Let's go. What do we have here? When I have one guy squared minus another guy squared, that's nothing more than the first guy plus the other guy. The product of the sum by the difference. The first guy minus the second guy. Is that right? That's exactly it here. I'm going to factor up and down to see if there will really be something that we can simplify. Let's factor up first. Open parentheses. Subtracting 3 of these 6 here, what is left? X to the power of 3, okay? More. In this term here, we are going to make only this factor disappear here, which is the x3, which was put out, right? So it will be a 2y, clasp. This one is scar, right? Now, this one is a little bit harder. Remembering there, our a will be x3 and our b 2y. Let's go then. How will it look? Here's what it will be. A, which is x3, plus b, which is a 2y, close parentheses, multiply by a 3, minus our b, which is a squared y. It even moves me. Look at it. Look how interesting. Look how simple even, in a way, for the sake of mit. I'm going to put it just like here, just like down here. What goes up above? The x3 is left, right? Underneath, what is left here, the x3. So that's it, guys. If you liked this video, don't forget to leave a like and subscribe to the channel for more content like this. Thanks.